Hi dear student, this is Sanal from Heal Bodhi classes. Welcome back to AS Level CAE 9702 series. In the last session, I have already explained the theory and concept of uncertainty, right? In today's class, we are going to practice some questions from uncertainty. Before starting the practice question, I will suggest that you should watch the previous video once again and recall all the concept and theory I have explained last class. How to practice? Okay, practice means when I give the first question, pause the video, take the screenshot, and spend time to solve it. Okay. After solving, you just watch the solution and check the answers and understand where you have made the mistakes. For the next question, remember your mistake and don't repeat that in the next question. Total 5 questions will be there. If you follow these methods properly, then I can guarantee you after the fifth question, whatever question you take from uncertainty, you will be able to solve that one. So let's start with the first question. This is question number 1. You just take a screenshot and pause the video. Start doing it by yourself. Okay? After finishing that, you resume the video and check the solution. Now I'm going to solve this question. What is this question first? A student records the length of a metal rod at two different temperatures. Temperatures are given 20 plus or minus 0.5, 80 plus or minus 0.5, right? With uncertainty, they have given the values. Length 502.3 plus or minus 0.2, 504.1 plus or minus 0.2, okay? These are the values. Length is changing with the temperature. Temperature increases, length is increasing, right? First part of the question A is determine the change in length of the rod with its absolute uncertainty. So I'm going to solve the first part of the question A. What you need to find out, this is the first step, okay? You read the question, determine the change in length of the rod with its absolute uncertainty, okay? First, what you need to find out the change. Every question will have a quantity to find out. Then second part is find the absolute or percentage uncertainty. So in here, what you need to find out, change in length with its absolute uncertainty. You find out the change first. Change in length, I am taking it as delta L. Always change is final value minus initial value, right? Final length minus initial length, which is equal to final length is 504.1 minus initial length is 502.3. When you put it in the calculator, you will get 1.8. You check which unit is this, mm. So change in length, you got it as 1.8 mm. Now what is the next step? Next step is you need to check the equation for calculating this value. What is this equation? Final value minus initial value. So it is subtraction, right? For addition or subtraction, you need to add the absolute uncertainty. So for addition or subtraction, you need to add the absolute uncertainty in the measurement. Absolute uncertainty in the measurement, okay, if you are changing L final minus L initial, what are they? 0.2 here, 0.2 here, right? So absolute uncertainty will be in the length measurement. I'm taking it as small l, okay? So it will be 0.2 plus 0.2, which is equal to 0.4 mm. So what is the value of change in length from the calculation? You got it as 1.8 mm. You need to represent it with the plus or minus the absolute uncertainty in the measurement, 0.4 mm. So either you can write 1.8 mm plus or minus 0.4 mm, or you can write it in a bracket and represent like this. Okay, this is the first part. So this is the answer for the first part. Next, second part. B. So second sub question from this. So what is B part? Calculate the gradient in expansion per degree Celsius, including the percentage uncertainty. So you need to find out gradient. Gradient G. Okay. With the percentage uncertainty. Gradient, how will you find out? You know that the gradient of a graph will be, okay, so this is x-axis and this is y-axis. If you take the gradient, what is that? Change in y with respect to change in x, right? So gradient is always, you remember this one, it is change in y with respect to change in x, delta y by delta x for any graph. Here you need, they have specified in the question expansion per degree Celsius. So when you check y-axis, what you will put? Expansion, right? In y-axis, what you will plot? Expansion. That means change in length upon delta T. Temperature change, right? So gradient of the graph, when you check, what is the change in length here? Change in length here, you already got it as 1.8 mm divided by, what is change in temperature? Delta T. Change in temperature is 80 minus 20. Final value minus initial value, okay? 80 minus 20. When you put these values in the calculator, you will get 0.03. The unit you check, mm per degree Celsius, right? Per degree Celsius. So you got the values now. What is that? G. How will you calculate that one? Delta L by delta T. First part you got. What is the value for gradient? So you got the gradient as 0.03 mm per degree Celsius. Now what is the next step? Uncertainty you need to find out, right? So uncertainty. Uncertainty, you need to check the equation, okay? Which operation you have done? Gradient delta L by delta T, right? So you have divided, division has done. So uncertainty calculation for division and multiplication. For division and multiplication, you need to add the fractional uncertainty or percentage uncertainty. These two rules you need to remember. For addition and subtraction, you will add absolute uncertainties. For division and multiplication, you will add the fractional uncertainty or percentage uncertainty. Clear? So add fractional or percentage uncertainty. Got it? So now fractional uncertainty, use fractional uncertainty always, okay? It will become easier. So fractional uncertainty, you check for gradient, delta G upon G is the fractional uncertainty, right? Absolute uncertainty upon average value. Equal to, first measurement comes from the length. So delta L upon L plus second fractional uncertainty in measuring the temperature. So delta T upon T. Is it clear? Now you substitute the values. So delta L, what is the change in length? 1.8, right? Now you substitute the values. So what is delta L? Change in length, absolute uncertainty is 0.4. So 0.4 upon, what was the length? 1.8 plus. Next you need to find out the absolute uncertainty in the temperature measurement. Temperature change, what is the temperature change here? 20 to 80, 60. Two uncertainties 0.5 plus 0.5, right? So it will be 0.5 plus 0.5 upon 80 minus 20, 60. When you put it in the calculator, you will get this one will be 0.222 plus 0.017. So which will be equal to 0.238. Okay. So this is the fractional uncertainty in the measurement delta G by G of gradient. So you know that fractional uncertainty multiplied by 100, you will get the percentage uncertainty. This will be approximately equal to, if you multiply with 100, what is the percentage? 23.8 percentage uncertainty is there in measuring the gradient. Okay, you remember that this error is propagated because you have measured certain values, delta T and delta L, and you are using that value to calculate gradient. So that error is propagating, right? So total 23%, 23.8 percentage error is there. Now the representation when you check, so you need to find out the absolute uncertainty in the gradient. So you cross multiply this one 0.238, you multiply with the gradient, then you will get delta G, right? So delta G is equal to absolute uncertainty. This is absolute uncertainty in gradient measurement. Gradient calculation. Okay, gradient is not measuring, it is calculating using the measured value. So this G in absolute uncertainty in G will be 0.238 multiplied by, what was the G value we have calculated? It was 0.03, okay, 0.03. So 0.03. When you put these values in the calculator, you will get 0.0075. Then you need to represent the gradient. Gradient G equals, what is the average value you got? 0.03 plus or minus the absolute uncertainty. So how will you write it? Gradient plus 0.03 plus or minus 0.007. You can round it off to 0.008. Okay, with the unit you need to mention. Okay, what is the unit here? Extension you have measured in mm and per degree Celsius, right? This is the unit with approximate percentage. If you are writing in percentage, 23.8 percentage uncertainty. This is percentage uncertainty, right? This is the representation of the quantity you have calculated, which is gradient. So this is the second part. Next is C part. C, when you check, comment on whether the change is significant compared to the measurement uncertainty. So measurement uncertainty means it is, they're not asking about the gradient, they're measurement uncertainty. Measurement, which all things you have measured? You have measured delta L and delta T, right? So when you check the measurement uncertainties, you check this gradient calculation. So here, this is the fractional uncertainty in measuring the length. This is the fractional uncertainty in measuring the temperature. You check this one. What is the value? Percentage uncertainty multiplied by 100, 22.2 percentage. And this one is 1.7 percentage. Correct or not? So when you compare this uncertainty, you know that 22.2 percentage uncertainty is there in 1.8 mm measurement, which is significant, right? So how can you phrase that answer? In 1.8 mm change in length, there is 22.2 percentage of uncertainty is there. So uncertainty is not negligible. Use more precise instrument to measure length. This is how you are going to solve the question. So you need to remember what are the steps we have followed. First one, you will find out the average value using an equation. Then what you need to find out? Uncertainty, right? Uncertainty. Before finding out the uncertainty, you need to check what operations you have done. addition, subtraction, multiplication, division. So if addition or subtraction is there, you need to add absolute uncertainty. If division or multiplication is there, you need to add the fractional or percentage uncertainty. Clear? Then represent the quantity with average value plus or minus absolute uncertainty or percentage uncertainty. Clear? So we will move on to next question. Question number 2. Okay, pause the video and take a screenshot and do it by yourself. Okay, now I am going to solve this question. What's the solution? Okay, a sample of metal has a mass. Mass is given. Diameter, measured diameter is given. Height is given. Okay, all are in mm and gram. So you have checked the unit. So first part is A. Calculate the volume of the cylinder with its percentage uncertainty. Okay, volume you need to find out. Volume general formula, what is that? Base area multiplied by height. Correct? So for a cylinder, what is the base area? Circle, right? So there's a diameter is given. What is the formula for area? Area is equal to pi by 4 d square or pi r square. This is the area of a circle, right? Since the diameter is given, we can use pi by 4 d square formula. Pi by 4 d square into height h. So all values are there. Diameter is measured and height is there. What is the value? Average value. You need to substitute in this equation and calculate it. So this is the equation. You have all the measured value d and h. So you need to substitute those values. Before substituting the value, you just check one thing. The unit, okay, gram, mm, right? The final one more answer you required gram per centimeter cube. So you can convert this into centimeter. So centimeter, to centimeter divided by 10. So the values you substitute 1.640, right? Diameter. So pi by 4 into 1.640. You need to square it, multiplied by what is the height? Height is 52.3 So it will be 5.23 centimeter. So it will be 5.23 centimeter. So when you substitute all these values in the calculator, you will get it as 11.047, approximately equal to, round it off, it can be 11.05, right? You can write it like this. So it will be in centimeter cube. What is the unit? Write the unit always, okay? So volume average value you got. Now what you need to find out? You need to find out the uncertainty, right? Question you check. You need to answer the cylinder with its percentage uncertainty. So uncertainty, when you are checking volume equation, you check what is the operation for uncertainty. I'm writing it, okay? For uncertainty, what is the operation you have done? Multiplication, right? So it is multiplication. For multiplication, what is the rule? You need to add the fractional uncertainty or percentage uncertainty. So fractional uncertainty, delta V by V in measuring the volume. Which all things you have measured? Diameter, delta D by D, plus delta H by H. Now you check what is the power. D has a power, right? That power you need to multiply, D square. So this will be 2, this into 1, right? For height, what is the power? 1. Power always you need to multiply. Correct? So delta V by V is equal to 2 into, what is delta D here? 0.05 divided by 16.40. Okay, if you are substituting the value, you don't need to convert here, because if you convert also, that will get cancelled. So this values you can directly substitute from here. 0.05 divided by 0.05 divided by 16.40 plus delta H. What is that value? Delta H is 0.1 is the absolute uncertainty in the height, divided by 52.3. 0.1 divided by 52.3. When you substitute all these values into your calculator, and you will get 8.00 into 10 to the power minus 3. So you can write it as 0.008, which is approximately equal to, multiply by 100, you will get the percentage uncertainty, right? 0.8 percentage uncertainty is there in the volume. Now, in terms of fractional uncertainty, absolute uncertainty, you can represent it. From this, you know that delta V by V, that is the fractional uncertainty in the volume, will be equal to 0.008 is the fractional uncertainty. If you want absolute uncertainty, delta V, absolute uncertainty will be 0.008 multiplied by the volume. What is the volume calculation? You have calculated 11.40047, right? So it will be 11.047. Put it in your calculator and you will get it as 0.088. 0.088. So volume, how can you represent now? Volume equal to average value 11.047. 11.047 plus or minus 0.088. So it is 11.047 plus or minus 0.088 centimeter cube is the volume. So you can round off and write it in a suitable significant figure. So 11.05 plus or minus 0.09 centimeter cube. This is the volume. Then approximately equal to what percentage? 0.8 percentage uncertainty. Understood? This is your answer for part 1. Now moving on to the part 2, determine the density with its absolute uncertainty. Now here absolute uncertainty, okay? So second part B, density, rho. So you know the density formula, what is that? Mass by volume. So mass is given, mass 125.6 is the mass, grams, okay? What is the unit? Gram. 125.6 upon what is the volume? 11.05. When you put this in your calculator, the value is 11.366. 11.366 gram per centimeter cube. Okay, this is the density. Now what do you need to find out? Uncertainty. Uncertainty, when you check the operation, mass by division, right? Mass by volume, division. So division, what you will do? You will add a fractional uncertainty. Delta rho by rho, this is the fractional uncertainty in the density. This will be equal to first measured value mass. So delta m by m plus delta v by v, right? So now you substitute the values in this equation, delta m by m. What is the uncertainty in the mass calculation? It is 0.1 grams. So you can substitute that 0.1 upon what was the mass? 125.6 plus delta v by v, volume with absolute uncertainty, you know, then you can use those values. Delta v is 0.09 by 11.05, right? Put these values in your calculator. Approximately 8.94 into 10 to the power minus 3. So you can write it as 0.0089, right? Divided by 1000, 0.0089. So this is the value you are getting. So delta rho by rho, fractional uncertainty in the density, will be equal to 0.0089, which is approximately equal to, multiply by 100, you will get a percentage uncertainty, right? So 8.9, you can write it as 0.9 percentage uncertainty. Okay. Now you need to find out the absolute uncertainty in the density. That is the question. You represent it with the absolute uncertainty. absolute uncertainty in the density measurement is delta rho, so it will be 0.0089 multiplied by the density value you have calculated. What was the density value? 11.366. 11.366. So put these values in the calculator. When you put these values in the calculator, you will get it as 0.9 into 11. So you will get the value as 0.101. Okay, that is the absolute uncertainty. Then unit is what? Gram per centimeter. You have converted already, right? Centimeter. So how can you represent density now? Density is equal to average value you have calculated. What is that? 1.3666 plus or minus 0.101 gram per centimeter cube. Density rho. So round it off and write it in suitable significant figure. So I can write it as 11 point, right? This was 11, sorry. So 11.4 plus or minus 0.1 gram per centimeter cube. This is the answer. So C part is the manufacturer claims the density is 7.85 gram per centimeter cube. Discuss whether the claim is acceptable or not. So you have calculated the values with the uncertainty. It is not acceptable, right? Because it's given only 7.85 gram per centimeter cube. You calculated it is 11.4, right? Even not in the range of uncertainty also. So the claim is not acceptable because the calculated value is much greater than the claim. And out of the range of uncertainty. Okay, understood? So we'll move on to the next question, question number 3. You pause the video and try to solve it by yourself. And after getting the final answer, only you will continue watching the video and check where you have made the mistakes. A toy car moves from rest along a straight line track. A motion sensor gives these measurements. Distance and time is measured using a motion sensor. Assume constant acceleration using s is equal to half at square. Calculate the acceleration with its percentage uncertainty is the first question. Then identify which measurement contributes the larger uncertainty and explain why. Suggest one improvement for reducing the overall uncertainty. So we'll start part A. Calculate the acceleration. So calculate the acceleration. You have the equation. What is given? S is equal to half at square. So you required A, solve for A. A is equal to 2s by t square. This is the equation. So the displacement and time is measured using a motion sensor and the values are 95.0 plus or minus 2 centimeter. Okay, centimeter, and this is in seconds. So do you require to convert this one? No. Okay, you can calculate in centimeter. So they didn't specify any unit, so you don't need to convert it. So you directly substitute the value. 2 multiplied by 95.0 divided by time is 2.17 second. You square it. When you put these values in your calculator, you will get 40.349 centimeter per second square. So this is the acceleration. You have find out the acceleration. Now you need to find out the uncertainty, right? So you will check the equation. What is the division is there, right? For uncertainty, division rule. For division, what you will do? You will add the fractional uncertainty. So fractional uncertainty in acceleration, you can write like this, which is equal to the measurement is done in a distance, which is delta S upon S, plus the fractional uncertainty in time measurement delta T by T, and you need to multiply the power. Okay, 2 is there, so 2 times delta T by T. So substitute the values from the given data. Delta S is 0.2, 0.2 upon 95.0 plus 2 multiplied by delta T uncertainty in time. What is that? 0.01, 0.01 upon 2.17. So you put all these values in your calculator. So you will get the answer as 0.113, 0.0113. Okay, which is approximately equal to, multiply by 100, you will get the percentage uncertainty. So 1.13 percentage uncertainty is there. Now you need to find out the fractional uncertainty in the acceleration. Delta A by A, which is equal to 0.0113. So absolute uncertainty in the acceleration will be equal to 0.0113 multiplied by the acceleration. So you have already calculated the acceleration. So 0.0113 multiplied by 40.349. So you put this value in your calculator. You will get the answer, absolute uncertainty in the acceleration, as 0.4568. Okay, so in acceleration you can represent acceleration A equals the average value, which is 40.349, plus or minus the absolute uncertainty in acceleration 0.4568 centimeter per second square. Right, now you round it off and write it in suitable significant figure. So you can write it as 40.3 plus or minus 0.5 centimeter per second square. Okay, with the approximate uncertainty percentage uncertainty 1.13 percentage. So this is your acceleration. So you got the answer now. So this is the answer for part A. Now part B, what is that? Identify which measurement contributes the larger uncertainty and explain why. You check the uncertainty values. When you check the uncertainties in distance measurement and time measurement uncertainty is more because it is squared, right? So you can phrase the answer from calculation. Uncertainty in the time calculation is large because it is squared in the equation, right? Suggest one improvement for reducing the overall uncertainty. So more uncertainty is in time measurement. How can you suggest? The more uncertainty is in the time measurement, right? So you need to use more precise. What is the instrument used here? Motion sensor with a high time resolution. So use more precise time measurement motion sensor. Higher time resolution. Okay. One more method, if you want, you can write what is that when you calculate the total uncertainty, you can see that this is delta S by S. If you increase this value, denominator, what happened? The overall value will decrease, right? So you can increase the distance also. Increase distance to reduce fractional uncertainty from distance. These are the two methods. In question, they have asked only one, but you can analyze the question according to the situation and you can write. A spring is hung vertically and its extension is measured for a non-load. Loads are given from 0 to 5. Length is changed from 14.2 to 17. Okay. First part is determine the extension with its absolute uncertainty. Extension. Extension means delta x if you want to find out. So delta x is the change in length. The change in length will give you the extension, right? So length final minus length initial. So final length is 17.0 minus initial length is 14.2. So this will be equal to, what is the unit here? Centimeter. Okay, centimeter, nothing is specified, so you don't need to convert it. So it will be 14.2.8 centimeter. Okay, so you got the length, change in length, that is extension. So uncertainty, what is the operation? Subtraction, right? Subtraction means you need to add the absolute uncertainty in both the measurement, right? So delta L is equal to uncertainty in measuring the change in length 0.1 plus 0.1, which is equal to 0.2. Okay, so how can you represent this one? This one is 2.8 is the value, plus or minus 0.2 is the absolute uncertainty. This is in centimeter, and this is the extension, change in length. So this is the answer for first part. If you want, you can convert this into meters. So it will be 0.28 centimeter to meter. So it will be divided by 10, 0.28 plus or minus 0.02 meters. Okay, why I did this conversion? Because usually spring constant is represented in Newton per meter. Okay, so I'm using this conversion and I'm finding out the spring constant. Next part B, spring constant. Okay, in Newton per meter I am calculating. Okay, so K equation is what? F over X, change in force upon change in length. Change in force from 0 to 5, right? Final minus initial, 5 minus 0 upon change in length, already you find out, which is 0.28, which is equal to, when you put this in value in your calculator, you will get 178.57. 178.57 Newton per meter. Okay, so this is the spring constant. Now you need to check the uncertainty. So uncertainty, what is the operation? Division. So delta K upon K, this is the fractional uncertainty. You need to, for division, what you will do? You will add the fractional uncertainty. Delta K by K, which is equal to delta F over F plus delta X over X, right? So if you check this one, force uncertainty is not given, so you will consider it as 0. There is no uncertainty in the force, so it will, the uncertainty is contributed by elongation only, right? So you have the values. What is the uncertainty in the elongation value? 0.02. You need to, if you are using meter, you need to take this value. Okay, so 0.02 upon 0.28, which is equal to, when you put this value in the calculator, so you will get 0.071. So which is approximately equal to, multiply by 100, you will get the percentage uncertainty. 7.1 percentage uncertainty is there. So this is delta K upon K, which is equal to 0.071. So you can find out what the absolute uncertainty in finding out K, which is equal to 0.071 multiplied by K, the spring constant. That value is there, 0.071 multiplied by K. K is 178.57. 178.57. So when you put this in your calculator, it will be 12.678. So 12.678. What is the unit? Newton per meter. So your value, your spring constant K, you can write what is the value. Average value is 178.57. 178.57 plus or minus 12.678 Newton per meter. Then you round it off and write it in a suitable significant figure. So 178.179 you can write, right? 179 plus or minus 12.6, you can write it as 30 Newton per meters. Newton per meter, with approximate uncertainty in percentage uncertainty is what? 7.1 percentage. So this is the value for K. This is your answer. Okay. So next part is what? State whether the dominant uncertainty comes from force or length measurement. So force, we didn't consider any uncertainties here. Okay, we assume that it is having no uncertainty, but actually it will have uncertainty, right? The dominant uncertainty comes from length measurement. So you can write like that. You can phrase it like this. See, no uncertainty given for the measurement of force. Measurement of force. Force also had uncertainty which we didn't consider. So uncertainty in K is only due to length measurement. Okay. So we will move on to the next question. So this is the last question, fifth question. I'm giving this question to you for practice. You do the question and comment your answers. If you are not getting the answer, I will solve this question and post it in the doubt clearance playlist. Okay. I hope you understood the method of analyzing and solving uncertainty question. Why I am writing all the steps means when you watch it, okay, you need to initially you need to follow those steps, then you won't make mistakes. So I will give you the steps one more time and you remember those steps and try to follow those steps to solve this question. Okay, so steps to analyze. And solve uncertainty questions. First, you need to check the readings. Okay, check the readings with the unit. If any conversion is there, you need to do that conversion initially. So check given readings with units If any conversion is required, do it. That is the first step. Second one, use the equation. If the equation is given, for example, the third question, no acceleration question, it is given s is equal to half at square. From that question was acceleration. So you need to solve for acceleration. Then use that equation to find out the average value. So use the equation to find the average value of the quantity. The third step, after finding out the average value using that equation, you will check the equation for the uncertainty algebraic rule. Whether addition, subtraction, multiplication or division is there, then you will apply the rule. So check the equation for uncertainty algebraic rule. In that, if you are finding it's addition, if it is addition or subtraction, what you will do? You will add the absolute uncertainty. Remember this one, you need to add. If addition or subtraction, you need to add the absolute uncertainty. Okay. Second, if it is division or multiplication, what you will do? You will add the fractional uncertainty. After finding out the absolute or percentage uncertainty, what you will do? You will represent that quantity with the absolute or fractional or percentage uncertainty. So represent quantity with absolute or percentage uncertainty. Now you understood the procedure to solve uncertainty question, right? This is the procedure. If you remember this procedure and you practice 5 to 6 questions, then you are not going to lose mark from uncertainty calculation. Okay. So one more time I will explain how to do it. First, you need to check the readings, measurements given with the uncertainty and check the unit. If any conversion is required in the answer, then you need to do that conversion also. Conversion, you may make mistake. Okay. Second one, after checking the measurement, you will find out the equation, right? You will find out the equation. Using that equation, you will find initially what is the average value of the quantity. Then after finding out the quantity, you will check that equation and what operation is done to calculate the quantity. What is that? For maybe addition, subtraction, multiplication, division, right? If addition or subtraction is there, you will add the absolute uncertainty. And if division or multiplication is there, if you will find the fractional uncertainty or percentage uncertainty. And finally, you will represent the quantity with the average value plus or minus absolute uncertainty or percentage uncertainty. Clear? So you remember this procedure and try to solve this question by yourself and comment your answers. Okay. So in the next video, we will do some interesting MCQ questions. After that, two more topics are there. One is principle of homogeneity and vectors. Okay. With those two videos, we can finish this module. So see you in the next video. This is Sanal from Hilbodhi Classes. Bye.